welcome back. Finishing off the modeling section, we now used the Shapley values to reduce our number of features, and very iterative. We went from 188 features down to 30 something. It will depend, but roughly about 30 important features. It was a process, but we were able to really limit the number of features and still have roughly about the same predictions, which is very valuable. And so here what we're going to do is we're going to do train test. So we'll do x train, x test, y train, y train, test split, and we're going to give it our and we're going to do it a little bit different here. What we're going to do is we're going to do the beats, and then what we'll do is we'll do the target. Put our data set up that way. We'll do test size equals to 0.3 or 0.3, and then what we'll do is our next step is to do the random to 42. Okay, so we're going to do a fitting of our model now. So we have our feats, and we're taking that, and okay. So here what we're going to do is we're going to do our feats. So we're going to do our model. So we'll do model dot fit, and we'll fit it with x train, y train, and then we're going to get our training score. So we'll do this. Really, what's this score train? So let's do score train equals to model dot score x train y train. Okay, and so what we're going to do here is we're going to copy this into the line down below, professional coding, and paste this right here. And just make sure that our index are all aligned up here. It's not going to the right place. Let's do a space. Okay, one by one. Okay, there we go. And lining that all up. And so here what we want to do is our return feature. So return x train, and we're going to do cross validation scores next. Okay, so we're going to do cross validation scores. So it'll be score dots or underscore CV equals to, we're going to get the average of all these scores, so NP mean, and we're going to give it cross val score, and we give this the model. We're going to give it the beats, and we're going to give it the target. And then what we're going to do is we're going to go CV equals to 10. And there we go. So now we have all of our values. We have our score, and we're going to make sure we change this one to test. So train score, test score, cross validation score in our model factory. So we're going to build a model and then train it. And this will allow us to train many different models. And so here we're going to do our features. Here what we're going to do is, you can see we have our 3 scores. We're going to call this function in the next function. And so it's a very simple use of kind of using 2 functions together, but this, again, this is where you start to get the value of using programming properly. And so here what we're going to do is we're going to call model factory, and what we're going to put into it is we're going to put our model, and that we're going to put the model that we're getting out from the list of models that we're going to create, and we're going to get then the we're going to give it model, and we need to give it the feature. That's fine. So we're going to iterate through a list of features, which will be there 2 different lists. So when we use these functions, it'll make more sense when we use these functions right here. So we're going to create a list of our features. This is a tuple inside of a list. This is in the first position in the list. So this is ARD regression with ARD, just so that we can call on that name. So it's kind of like a tag so that we can put it into our data frame. Then we're going to features 1, features 2, just to kind of look at the difference of our scores, and then model, and then features. And so put those in. And so we can see here when we put these in, so we give it our list of our models and our list of our features and what comes out of this. And I should actually do this one last line right here. Sorry, I forgot to do one line. We're gonna make a list right here. So you'll go, let's call it num feats. And then that's equal, or not equal to, that's the key, and the value pair. So the value that pairs with that key is going to be num. We're then going to go train underscore score, and then that is the key, and our value pair is going to be train scores. Our next one is going to be test scores, and our value pair is going to be test scores. And so I actually don't like to call it, I like to call it train score the column title, so test score, and we're going to give it the list of our test scores. And the last one is we're going to get our CV score, and then we're going to get our CV scores. Okay. So now we're done. Now we're going to put that in the dictionary, get our little data frame. And so when we put it in like this, we're going to get our model, and we're going to be able to put the names beside that. We're appending that for each one here. We can see that in our model name, we're appending that for each one in the loop. So it gets appended twice here because we have 2 features, and we go through. We can see that with the ARD regression, we get, with all of the features, 173. We have 85 score, which is quite good. With only 33, we have 389. So let's actually run this, because I think we ended up having a few more. So now when we run this, you can see that it takes a little bit. It's a lot of features, even with the ARD regression, which is truthfully quite simple. So now that we run that, we can see we get our model scores here, and a little bit of time. And this is because the cross-fold validation is essentially doing 10 cross-folds. And the reason I wanted to see this is because when we do our final predictions, we're going to want as much data to train our data set off. So we're going to use close to as much of the data as possible. We want to value how good of predictions we make. So doing the cross-fold validation will give us a good idea of that. Okay, so we can see here that we have our data set. So we start with 172 features, and we got down to 33. And so here what we have is 84.7, and then we got to an 82. And I think the most important thing is looking at the cross-validation scores here. We can see that on average, as we go through the whole data set, we get a 0.38 and we get a 0.827. So 0.003 difference in cross-validation score by only using, I don't know what percentage of that, a very small percentage, 15% of the features. And it's really the value in using Shapley values. It's really, really great value. So looking at the coefficients then of the model, our ARD regression, and we can see here we got the coefficients of all the values. Ones like this that are really low, we could eliminate as well. I really find that every time I eliminate it and then look at the score, it does seem to add value. Although the coefficient is quite low here, it still really seems to add value, and the pool area as well. And my guess is because these numbers are quite large, although we standardize, it still makes a little bit of a difference. Here we have a workflow just to select different models, kind of comparing. So ARD regression, linear regression, elastic net, and then gradient boosting regressor, bagging regressor, and some different hyper features that I've set for both of those. So if we run that as well, we can see here, let's see what we get for these models. So this is also going to do 10 cross-fold validations for each one of these. This is going to take a little bit, so I'm going to time warp into the future, and I'll see you in a few seconds. And now that it's run, You can see our gradient boosting regressor has the best score when it uses 172 features, but it does very, very close to the same score, only 0.02 difference with only 33 features, which is really quite amazing from 172. And that was really the selective feature reduction that we did with Shapley that allowed for this to be possible. So going through this, and we can see that the elastic net did the worst. ARD does quite well, really in all comparison. They all do quite well, really very, very close. But the gradient boosting regressor seems to be the best in both situations, with most features and without. So you could use all of the features and maybe you'll get a better score. And so we will, I'll show you how to set up the competition predictions in the next video. Okay, see you in a sec.